Cool beans. Chat, we did it. Largest palindrome. That's a classic. So got private functions here. Next up. Yeah. Screw it. We're making the largest palindrome product. It takes really simple base. The largest palindrome made from the product of two-digit numbers is 9009. Oh, so a product of two numbers that gives a number that is a palindrome. Okay. So find the largest palindrome made from the product of two three-digit numbers. So I guess we got one for a variable, the number of digits for numbers. So let's say D, which represents digits, and initially let it be for two digits. Alright, and so we're looking for two-digit numbers going from 10 to 99, multiplying them, getting a number and checking if that number is a palindrome. 9009. What would be the efficient way of solving this? It's not really straightforward. So the most naive approach would be to go through all possible combinations. So let's say from 100 to 999, we take 100 and try to multiply it with 100, 101, and so on. Although it would be better to start from the biggest numbers, since we're looking for the largest palindrome. So we would start multiplying 999 with 999 and checking if that is a palindrome. I don't think it is. No, it's not. This also isn't. Right. Wait, that's... Yeah. Okay, so we're looking for a palindrome. So we're making in either a range from 99 with two digits to 10, or for three digits it would be 99 to 100, right? So I could maybe like create a string adding nines. So let's say A is n and reduce for 1 to for D, and reducing, and we got an empty string in the accumulator, because I'm not sure. We can check for integer module for some kind of a concat, but I don't think that exists. What's this? Digits. Interesting. We've got parse. string on digits. Oh. This turns a list into a number. This turns a number into a list. Oh. Right, so yeah, we could use undigits, I guess. And just so something like we're making a list integer on digits, and here we got a list of range 1 to 2, where element is not really important, we're just giving 9. Alright. Yeah, 99. If we add 3, we have 999. And so for 10, or we would have to do it a little bit differently. We would need to start with 1 less 0 add to the list. So it would be I don't know if I can do something like this. So integer on digits, like a list. It starts with 1, but in the rest part, we actually have this to -1 function 0. And then we close the list and create it into an integer. Yeah, it works, and it's exactly what I want. So A would be integer on digits in a map 1 to D 9. Alright. And B, part of the range, is something similar, only we start with 1, and for the rest of the list we enumerate over 1 D minus 1, and 0. Alright, now we got our range depending on the digits, and then now we're looking for our palindrome. Alright, and we might use digits to determine if it's a palindrome. Because let's say, first I can check if the list is even, right? If it's even, then we should check really if it's a palindrome. If it's not, it can still be a palindrome. That's true. In fact, no, this is not a palindrome. Nothing of this is. Oh, we'll figure it out. So we got our range, and we should check. We should generate 2 lists that will be checked. Alright. So palindrome product, we're sending a range of A to B, so like 99 to 10 for the example, We're sending it 2 times. Okay. Because we'll do the combinations. We got a list now with some element. First list. And okay, that's the second list first. And we make a product of those 2 elements. And then we gotta check if Palindrome this product, then return the product, else we gotta continue Palindrome product. And we leave the first list as it is. And remove the head of the second list. Alright. Now we need some escape clauses, escape hatches. So Palindrome. So let's say we exhausted the first list and we got an empty one in the second list. Then we can just send the Palindrome product just rest one, right? So we got like 99. We tried to make a product with 99, 99, 98, all 99. Then we exhausted the list, and now we can start from 98, and also we already did 99, 98, so we don't need it. Just take the same rest list, so it would be 98 times 98, and so on. Also the last escape clause, so there's like 2 escape paths here, but also just in case we can add, what if we exhaust the first list, then this list would be also exhausted. In that case, we just turn nil. But this shouldn't happen, right? If our palindrome check is correct. Let's implement it. Add the question mark indicating that this function returns a boolean. So we can get list of digits for that product with integer digits for that product, right? So now we gotta check this list if it's a palindrome. So how would we do this? I'm curious, let's say I have a list and I got the length of the list, which is 3. And so if I use enum split A by division of length x2. What do I get? First part, second part, right? I guess for an odd, so maybe we should just split it into the even and odd part, right? So if we can add to a variable length the list of digits, and so if the remainder of length y equal to 0, we know that it's an even list, so it would be like splitting a list of 4 elements. We've got length A, which is 4, so we get this, and in this case the reverse of this should match the elements, right? But in case when there's just 3 elements, we would just want to have this and this. So it's like we would want to remove the middle element. Let's just check. We got something like list pop at, yeah. So div of 3, 2 is 1, and let's say I got a list 1, 2, 3. I would like to remove 2 in this list, which would be list pop at A on div of length of A 2. This should pop 2, and it did, and then we got an even list here. Alright, so then we can use just kind of split. So if it is even, we can get the split A, B, and split the list of digits with divisional length of length and 2. Got 2 parts. We will reverse the, we can actually do it like this. We could zip it. So we can start with A, and or maybe even B. Yeah, start with B, and we reverse it, right? And then we zip it with A, and then we check if all should be equal. We get this list, and we got X and Y, or A and B, whatever. Let's go with X and Y. And they should all be equal. So if they're all equal, then we know it's a palindrome, and this will return true. We also need the else clause, which would be the same, except we'll make a pop at the middle. We'll ignore the value and have the list of digits again. So list pop at list of digits at the division of length and 2. Yeah, right. This makes sense to me. So Let's find out if it works. Boom. No, it's not correct. I guess it's not the biggest one.
फिर भी चुक गया सोच उठी तेसी दर खोलने हथ रुकदा रुकदा रुक गया फिर भी चुक गया सोच उठी तेसी दर खोलने हथ रुकदा रुकदा रुक गया फिर भी चुक गया सोच उठी तेसी दर खोलने हथ रुकदा रुकदा रुक गया
How did you get 11? Oh, I get 10 here. Wait, what? Hundred? Oh, 1 to 0. Damn. So we got a palindrome. I'm not sure. We should find out what is the largest 3-digit number product. Largest palindrome for a 3-digit number product. 96609. Alright. So how did we miss that? Like, we should be starting with 999 times 999, right? And might have missed it because we moved this head, but that doesn't make sense because we multiply the head with everything in the second list. So why would it? What is it? What's the two numbers? What's the numbers? Damn. Man, why didn't you tell me the numbers? Sucks. Oh, here it is. 993 and 913. Okay, so maybe we can add some. We can add 995. Oh, I see. Okay, let's solve it like this then. We'll have the largest here, so accumulator of course, and we'll return the accumulator at the end, right? Okay, and each time we find a palindrome product, we go if the product is greater than accumulator, then call palindrome product. Yeah, I'll finish now. If product is greater than the accumulator, then we can send plug s again h1, rest 1, and rest 2, and product. It's the new max. Else we keep the accumulator as is, and then when we exhaust all possible iterations, we'll return the accumulator. Alright. There it is. Remove the debugging calls. Yeah. Okay, let's submit it. Yeah, this is correct.